Today we're going to take a look at integrals that involve natural logs. Okay, so we're not taking the integral of natural log functions, but we are taking integrals of functions that will give us natural logs in the solutions. So let's first write out a couple of rules. Okay, the integral of 1 over x dx equals the natural log of absolute value of x plus c. The reason for that, we always have an absolute value when we take an integral involving getting a natural log, because we don't know what the function started out as. It could have been positive or negative to begin with, and so that's why we have to have the absolute value. Also, integral of 1 over u du is natural log of absolute value of u plus c, okay, where u is a function of x. Now, the big thing here is you have to have your u and your du. Or some version of your du. Just like we did with integration by substitution, we'll be using substitution with natural log integrals. Okay, so it does get kind of complicated sometimes. Let's take a look at some simple ones to begin with, and then we're going to get a little bit more complicated. Okay, let's start with a basic. Let's say we have the integral of 2 over x dx. Okay, well, if it helps you, you could rewrite that as 2 times 1 over x dx, right? Integral of, we have 2 is just a constant. We'll keep 2. Integral of 1 over x dx, we said was natural log of absolute value of x plus c. When we just have a plain x on the bottom, those are super easy. We like those, but it does start to get more complicated. Oof, let's fix that. Okay, so let's try another one. Let's start to use our u substitution. Let's say we have 1 over 4x minus 1 dx. Okay, it's not just a plain x by itself. Okay, so we know we have to use our u substitution. Let's take a look. If u is 4x minus 1, then du, the derivative of that, would be 4 dx. So let's take a look at what we have in terms of u. 1 over 4x minus 1 is 1 over u, right? Now, du is 4 dx. We just have 1 dx, right? We only have 1 dx, so we have a fourth of the du. Okay. 1/4 is just a constant, so we're going to keep that. Now, integral of 1 over u du is natural log of absolute value of u plus c. Let's plug back in our u. Natural log of absolute value of 4x minus 1 plus c. That would be our final answer. Now, notice that we could take the derivative to check our answer and make sure that it works. 1/4 times u prime over u would be 4 over 4x minus 1. The 4 over 4 would cancel, and you'd have 1 over 4x minus 1. So it does work. You can work backward really quick if you would like to check your answer and make sure it makes sense. All right, let's try one. We're going to kick it up a notch. We're going to do a definite integral. Okay, let's say we have integral from 0 to 3 of x over x squared plus 1 dx. Our u is going to be what's on the bottom, x squared plus 1. Du would then be the derivative, 2x dx. Okay, I'm going to make some side notes over here to the side. Let's rewrite in terms of u. Okay, the x squared minus, or x squared plus 1 on the bottom, we can call that 1 over u. Now we're left with a plain x dx. Our du is 2x dx, so we've got 1/2 of the du. So 1/2. Okay, 1/2 is just a constant. And then integral of 1 over u is natural log of absolute value of u plus c. Now, we don't need the plus c because we're doing a definite integral. So let's go ahead and come over here and plug this back in. 1/2 natural log of absolute value of the u plugged back in, x squared plus 1. And then our vertical bar, because this is a definite one, let's put in our limits of integration. We want to start by plugging in 3. So we have 1/2 natural log of absolute value of 3 squared plus 1. Actually, I don't need absolute value anymore. So because I'm going to get the actual value. 3 squared plus 1 would be 10 minus 1/2 natural log. 0 squared plus 1 is 1. Now, we know natural log of 1 is 0, so this part is gone. And we simply have 1/2 natural log of 10 as our answer for that definite integral. And you will usually leave this as just as simplified in terms of natural log. The only time it might be different, let's say it's a calculator active problem. This is too easy to be a calculator active problem. But if it were, you would just type it into the calculator to get the absolute, get the natural log of 10, divide it by 2, and you should end up, whoops, if you needed the decimal for whatever reason, that would be not 0 point. That would be approximately 1.151. Okay, but again, usually you're leaving these in terms of natural log because usually these are calculator inactive questions. All right, let's try one with trig as well. I won't do a definite one, but we'll try one with trig. Let's say we have the integral of secant squared of x over tangent of x dx. Now, this is probably where people start to get confused and say, well, how do I know that I have to use, that I'm ending up using a natural log? To which I would say you might not know that to begin with. But if you start to take a look at this one, I would immediately recognize, hey, I have a tangent and the derivative of tangent is secant squared. So I'm probably going to be using u-substitution where my u is tangent. Okay, so that's where my first thought goes. U is tangent. That means du, the derivative, would be secant squared of x dx. Okay. Now, as we start to rewrite this in terms of u, the tangent on the bottom means that's 1 over u. And then secant squared of x dx, that's just du. Now, this is where we realize, hey, I'm going to use natural log. Because I'm going to have integral of 1 over u du is natural log of absolute value of u plus c, which would be natural log of absolute value of tangent of x plus c. Now, I do want to kind of take a look at one that looks similar, but might involve something else. What if we had secant squared of x over tangent squared of x? We could make our u still tangent of x. Our du would still be secant squared of x dx. Okay, but our difference would be when we rewrite this in terms of u. Think about this. Tangent squared on the bottom is 1 over u squared, right? And then secant squared dx is du. Well, that's the same thing. 1 over u squared is the same as u to the negative 2 du, in which case we don't need a natural log when we take that integral, right? Integral of u to the negative 2 is u to the negative 1 over negative 1 plus c, which is just negative 1 over u plus c, which would be negative 1 over tangent plus c. Okay, so notice the difference in the solutions here for these two problems as far as the integral. Even though they look very similar to begin with, the only difference is that the tangent has an exponent on the bottom. Remember, natural log is only used when the exponent is 1 on the bottom. Okay, so just be careful about that. We're going to do some practice assignments where you kind of try to figure out when you're using natural log and when you're not, and you're just using regular u-substitution, because that can be probably the hardest part, is putting this all together, taking a look at a lot of different integration problems and figuring out when am I using natural log.